All right. So, like I said, lesson 8.1. This is an intro to the entire chapter, and we're going to be talking about sampling distributions. Sampling distributions. So, we're actually going to start with the activity today, and I'm not used to doing this virtually, so we'll see how it goes. All right. But what I want you guys to do is right now go ahead and measure your pinky in centimeters. Okay, so go find a ruler or there's an app on your phone. Measure your pinky in centimeters. And when I say measure your pinky, I mean not including nails. All right, so just to the top of your pinky, no nail. And then I usually measure from the outside. I think it's a little easier, just to like this line where it meets your palm. So go ahead and measure that, and approximate it to the nearest like tenth. Okay. So go ahead and do that. Okay, so what I'm going to have you guys do is on this whiteboard, I put two scales. I'm going to have you guys put your pinky on the left-hand side. But what I want you guys to do is I want you to put like this X stamp where your pinky is. And you might need to round it. So it's every, like rounded to the nearest half centimeter, right? So if you're at like 6.3, you can round that to 6.5. Okay, so if that makes sense. So go ahead and hit the annotate button, and oops, it will be a stamp. Find the X, and then go ahead and plop the X on the left-hand one. Oh, you don't want remote control. You just want to annotate. Person who asked for control. Oh, try not to overlap on other people's. You should be stacking. So I see a bunch of people stacked or overlapping on 5.5. I don't know if that's you, but move your X so that you're stacking on each person's. If you really can't find it, just type your pinky size in the chat box, and then I'll put a stamp for you. Okay, so you just type it in the chat box if you are having trouble finding it, and I'll stamp it for you. Okay, I got the 6. I got the 5.5. Got the 7. Got the 5.5. Okay, I'm gonna move these. I don't know if those are extras. I think they might be extras. So let me delete some of these guys. I'm assuming these are supposed to be moved over, so I'm going to move these over. All right, 7.5. Thank you. Got it. Okay. Ooh, somebody put it on the wrong scale. I'm assuming that's a 5. So I will put yours over here. How do we measure our pinky? With a ruler? Centimeters? So this is pinky sizes or size of period 5 in centimeters. But from where to where? Oh, I showed you guys outside. I don't know if this is a double up, so I'm gonna delete this one. Okay, 9.5? Really? Dang, that 9.5 pinky, right? 9.5? Really? Wow. All right. Let's see if there are 7 and A 3.75? Okay, so I will put that X for you at 4. Is that inches? Oh, I said centimeters, not inches. Okay, 9.5. Okay, so another 9.5. Okay. Wow. Interesting. Pretty large pinkies. Okay. All right. I think that's all the ones I see in the chat. Oh, you're the 9.5. Got it. Got it. Got it. Okay. Thank you. All right, guys. Well, this, by the way, in your notes, this is at the very bottom. Okay. It says sample distribution. Let's change that actually to population distribution. All right, so on your notes, change where it says sample distribution at the bottom, change that to population distribution. Okay, so this is our population distribution of our entire class. All right, so this is everybody's pinkies sizes. So that's population. Okay, so this is, I think, what we're used to. Now, what our main goal for today is for you guys to understand the difference between this population distribution and a sampling distribution. All right, the difference between a population distribution, which is what we're used to, versus a sampling distribution. Okay. Oops. All right, so in order to do that, what we're going to do is I am going to take a random sample of size 3. So I'm going to take a bunch of samples. So we'll do sample 1, sample 2, sample 3, and sample 4. And I'm just going to pick 3 people randomly to be in these samples. So when I call on you, just tell me what your pinky size is. And then I need a student to help me find the average. Let me randomly pick somebody. Megan Chow, do you have a calculator in front of you by any chance?
I do, yes.
Ooh, perfect. Okay. Can you help me find the averages of these samples?
Sure.
Thank you. Okay. So let's do this. We're going to make a sampling distribution. All right. Or at least the start of one. So sample 1, tell me what your pinky size is. Starting with Evan. Evan Chen, what's your pinky size to the nearest like 10th?
My pinky size was like 6.10 centimeters.
All right. Thank you. All right. So that's 1. Nick, what was your pinky size?
6.5.
0.5. Perfect. Thank you. And Avery, what was your pinky size?
5.5.
5.5. Okay. So Megan, go ahead and find the average of those 3.
6.03.
6.03. All right. So we'll go 6.0. And I'm going to go ahead and plot that average right there. All right. So at 6.0. Perfect. Okay. So that was our first sample. Let's try another sample. Let's go. Will, what was your pinky size?
9.5.
There it is. All right. And oh, Nick again. What was your pinky size?
6.5.
6.5. Perfect. And Nina, what is your pinky size?
6.
6.0. All right. Megan, go ahead and tell me what was that average?
7.33.
7.33. Okay. So I'm going to put a mark at 7.33. So that's like here. Okay. Yeah, you can copy this graph on the bottom of your notes. I think that could be helpful. Yeah. Like a sketch. It doesn't have to be exact, but like kind of the idea of it. Okay, awesome. Sample number 3. Let's go to Jessica. What is your pinky size?
5.5.
5.5. Perfect. All right. And then Scott, what is your pinky size?
5.5.
5.5. All right. And Cassidy, what is your pinky size?
6.0.
6.0. All right. So Megan, if you can find that average.
5.66.
5.66. All right, so I'll round that to 5.7. And let me put the stamp right there. Okay, and let's just do one more. Sample 4. And Malika, what is your pinky size?
6.
6.0, awesome. All right, Andrea, what is your pinky size?
6.
Okay, all right, and Tiffany, what is your pinky size?
6.
Oh, wow. Okay, so Megan, don't worry. I think I got this one. All right. And wow, I wonder what the chances of that was. Okay, so there is that X right there. Okay, so guys, what we are creating right here is a sample-ling distribution. So this is the beginnings of it. And what I mean by that is it's not the entire sampling distribution, right? Because we can keep going. We can keep taking sample 5, 6, 7, 8, all the way until, let's see, how many students are in this class? There's 25 students. So there is, let me see, if I kept picking three people, there are 2,300 different combinations of triples in this class. All right, 2,300, 2,300. Okay, so I would basically just keep drawing samples and keep finding averages, right? And then keep plotting them, keep finding samples, keep finding averages, keep finding samples, averages, etc., etc. And what's going to happen is this will all pile up. You know, some will be high, some will be low. Most of them will be close to this area, which is, you know, where I think our population center was actually. So we end up getting a bunch of these plots. Okay. So this is a sampling distribution. It'll look something like this. If we were to keep sampling and sampling, you know, same, you know, size, 3 people, 3 people, 3 people, and all different combinations of 3 people in this class, we would end up with a bunch of these averages, 2,300 averages that we would plot on this chart. And this is a sampling distribution, okay? So one of the biggest differences between this and our population distribution. All right, and I think this is key because a lot of times students will confuse these two all the time. So what I have found to be, I think, really helpful is just to think of what each like plot or what each X actually represents. Okay, so for example, in our population distribution, each plot or each X represents one person, all right, or one person's pinky. So each X represents one person, okay, in our population distribution. In our sampling distribution, I'll just do this X. Each X represents one sample, okay? Each X represents one sample. And a sample can be 3 people. Like in our, you know, example, you can have a sample of 10 people, 100 people, 1,000,000 people, right? Whatever sample size you have, but each X represents that one sample. So in this case, 1X represents 3 people, the average of 3 people. Okay. So I think that, you know, that concept is really important because a lot of times students will get stuck to thinking 1X means one person. But in a sampling distribution, 1X could mean 3 people in the sample, could be the average of 10 people in a sample. Okay? All right, so that is the difference between a population distribution and a sampling distribution. All right, let me take a pause and see if there's any questions. All right, if not, let me go back to the PowerPoint and you guys can go to the top of your notes now. All right, thank you, Megan. Okay, so a couple of notations to be careful about. Okay, so since we're talking about sample Leong distribution and every single one of those x's is from a sample, okay, some of these statistics, some of these values computed from a sample, the most common ones, the most popular ones that we're going to be using are these three. Sample mean, which is the x bar, an S, which represents the sample standard deviation, or p hat, which is the sample proportion. All right, so knowing this notation will come in very handy. So x bar for sample mean, S sample standard deviation, p hat for sample proportion. Okay. And just know that these observed values of the statistics will vary depending on the sample, right? We had different values from our sample means. We had 6.0, we had, something lower, something higher. So it just depends from sample to sample, okay? And that natural occurrence is what's called sampling variability. Sampling variability. And it's just exactly what it sounds like, right? It's just that every sample will vary just depending on which three people I happen to pick. Okay. All right. Now, this is the kind of like official or formal definition of a sampling distribution. Sampling distribution. Okay. So a sampling distribution is a graph. All right, first and foremost, it's a graph. It's a histogram or a dot plot like we saw that would be formed by plotting the value of a sample statistic, like a sample mean that we did, for every possible different sample from the population. All right, let me read that again. So sampling distribution is the graph or the histogram that would be formed by plotting the value of a sample statistic, like the sample mean, for every possible different sample from the population. All right, so that's why I found out how many possible samples could I get from our class of 2026. All right, and then I calculated it and, actually, sorry, I thought we had 25. We actually have more, so we have 26 people in this class. So there's actually 2,600 different combinations. All right, so there's 2,600. Isn't that crazy? 2,600 different sets of three people I can pick from this class. All right, so that'd be a big graph. All right, and that's what a sampling distribution is. So any questions up to this point, you can put in the chat or unmute yourself about what a sampling distribution is.